All right, guys. This is the second lesson for this week, compound interest. Compound interest, it should look real familiar to you. Last week we did growth and decay. Growth and decay is the exact same formula except for the ends. The N is where the compound comes in. All compound interest means is that instead of doing it once a year, compounding the interest once a year, it's compounding it multiple times a year. If you remember with the lesson we did, the very first one, I put a house value like $250,000 house, compounded for 30 years. Every year was a lot cheaper than if it was compounded daily. So that's where we are. So it's the exact same formula. There, the P stands for the principal. It's always 1 plus. We don't do any decay with compound interest, so it's always 1 plus the rate. The N, these two numbers will always be the same. That's how many times it's being compounded, and the T is the same. All right, so let's get some examples. The first example is one without a compound. It says, or it's compounded annually. Your parents give you a $3,000 loan for with 2.5% interest for 3 years. How much will you pay? So on that, when there's no compound, it's not being compounded other than every year. So it would just be you would use the one without a compound. All right, so we're going to use this formula over here. So $3,000 is our principal. All right. 1 plus, it's always 1 plus. The rate, change it to a decimal, so it's 0.025 for 3 years. And so we just plug that in our calculator. All right, if you have the 36X Pro, you can type it in just like that, and it'll give you, at the end of 3 years, you're going to pay your parents back $3,230.67. All right. But so now we introduced a compound. It says you get the same loan, $3,000, 2.5% interest for 3 years, compounded daily. All right, that one you're going to have to use the compound interest formula. All right, how much will you pay back to the bank? So it's still the same thing. You're still getting a loan for $3,000. It's 1 plus the rate, 0.025. But instead, now it's going to be over because we got to introduce the compound. Compounded daily is 365. Raised. Now N is going to be the same thing, so 365 times 3 years. And again, these two numbers will always be the same. All right. So when we plug that in our calculator and we hit enter, all right, you're going to pay back the bank $3,233.64. So whenever you introduce compounding, whenever it's been compounded, you're always going to pay more. Now in this case, it's only $3 more, but anytime it's compounded more than once a year, it's going to be more expensive than if it was not compounded. Or the more times you compound it, the more it gets. Just a reminder: semi-annually is 2, quarterly is 4, monthly is 12, daily is 365. We don't use days of the month. We just use monthly for 12, and so on. So remember, semi-annually is 2, quarterly is 4, monthly is 12, daily is 365. All right. So let's try 2 more examples, and that'll be it. All right. So Gina deposited her $1,200 stimulus check into the account yielding 3.4% interest compounded monthly. How much money to be in the account after 10 years? So she takes her check, she puts it in the bank, she leaves the loan. How much will be in there? So again, the principal, we're going to use this formula, all right, because it's being compounded. So our principal is $1,200. So we say 1,200 times 1 plus. It's always 1 plus. The rate, change it to a decimal, so that's 0.034 over the compound. Remember, N is the amount of times it's being compounded. Since it's being compounded monthly, that's 12. And then the 12 again up here. 12 times how many years? 10 years. All right, so I'll plug in my calculator. And I get 1,000. So after 10 years, that $1,200 turns into $1,685 and 13 cents. Again, if you want to practice with your calculator, pause it and practice the calculator. Make sure you're getting the same answer I'm getting. But also, if you don't have the calculator that does the order of operations for you, then you're going to have to do the parentheses first, then raise it to the exponent, and then multiply it by the 1,200. All right. So again, order of operations, parentheses, then the exponent, then the multiply by 1,200. All right. Last one. This is like the growth and decay where you had to use a little bit of guess and check. Your grandparents give you $2,000 for your birthday. You decide to put it in an account and at 5% interest compounded quarterly. How many years will it take for your money to double in amount? So again, you have to take what they give you. So they give us the 2,000, they give us the principal. It's always 1 plus since we're talking about compounded. Compounded at 5%, so 0.05. Compounded quarterly, so quarterly, there's 4 quarters. What they don't give us is the T. They don't give us the time. That's what you're going to have to play with until you double the money. So double 2,000 is 4,000. So that's just like with the growth in K, you just guess and check until you get above and below 4,000. All right. And when you do that with this problem, I just put it in my calculator and I started off with 10. It wasn't high enough. I went to 15. It was too high. And so I knew it was somewhere in between. And so I just narrowed it down until I got between 13 was below 4,000 and 14 was above 4,000. So somewhere between 13 and 14 years, it's going to take before that money doubles. All right. So use this formula. The formula is on your assignment sheet, so you don't need to memorize it. And you'll have it. You can use it whenever you take an assessment, all that stuff. So good luck on your assignment today. If you need help, I'm here for you.